Hey, imagine a bustling industrial area where factories process chemicals, create goods, and produce waste. Some of this waste, particularly wastewater filled with various chemical compounds, is properly treated and finds its way into natural water system.
Now, think about a small village where people draw water from a local well or spring. If industrial wastewater seeps into the groundwater, the water people use for drinking, cooking, and bathing could become contaminated. Drinking this contaminated water could lead to serious diseases like cholera, diarrhea, or polio.
The chemical contamination might also make the water hard, meaning it contains more minerals like calcium and magnesium. Hard water isn't generally dangerous to health, but it can have unpleasant taste and odor, and can lead to buildup in plumbing systems, reducing their efficiency.
We want to focus on the wastewater which is coming from textile companies. Wastewater from textile companies contains harmful things like heavy metals and dyes. Getting rid of this is essential but tricky. A common way to treat this water is by adding chemicals like sodium hydroxide. This makes the harmful particles clump together and easier to remove. This method uses about 600 kg of sodium hydroxide per month, costing $70 per 2.5 kg. So the total monthly cost is $45,000.
When it comes to graphene filter, which is totally different from the first way, graphene is a super thin material that can act like a super fine strainer. It's so fine that it can catch even the tiniest harmful particles, including those pesky heavy materials and dyes. You only need 1 kilogram of graphene per month, costing $200. With this, you can make a huge graphene layer of 130 square meters, enough to filter a lot of water.
Hello guys, today I want to talk about graphene layers, graphene pillars. Imagine this is a whole graphene layer without any hoods. And let's dig into the quantum physics, where in a kind of in atomic cells. And we can just imagine this as a water cell, heavy metals, heavy metal cells. And let's try to filter them with graphene layer. As you can see, nothing surpassed it. But luckily, the professor, the Professor Grossman from MIT University got a solution, got a final way to to open up a hole from graphene layer from graphene. And now it looks like exactly like this. Let's try to filter the water molecule and hear that molecule once again. As we can see, the water molecule easily surpassed it, but the heavy metal couldn't, and meaning that with the help of graphene filter, we can filter every single metal or every single gold cell or something like this, excluding water, and that provides us pure water to consume, to utilize in our daily basis.
May I ask a question? Why we need to choose your product? And we have an answer for this. Because our project is really cheap and easy to learn. Compared to other purification methods, you can learn this engine within an hour and it's really cheap. Also, if your engine filled with trash, you just need to change this filter, not full construction, and it will not cost you a lot of money. And this is also one plus of our project.